many DevDays. I'm calling in from Cologne. It's sunny over here. And our speaker today, Bryn Rhodes, will be talking to us about applying logic to FHIR with CQL. I'd like to welcome him, and he's calling in from Utah. So without further ado, I'll pass this on to Bryn for a short introduction. So could you unmute yourself, Bryn?
Yes, all right, thank you, Gustav. And thank you for joining. This is applying logic to FHIR with clinical quality language. Can you see my screen okay?
Yeah. Great.
All right. So my name is Bryn Rhodes. I am currently the Chief Technology Officer for a company called FHIR. We do consulting, and I spend most of my day doing healthcare standards development. I've got a background in software development and architecture, specifically information and database management systems. And I'm the co-editor of the clinical quality language specification and editor of the clinical reasoning module in FHIR. So learning objectives for the tutorial for today. By the end of this, hopefully, you should be able to describe clinical quality language, explain how and where it's being used, use CQL to express simple decision support logic, include CQL content in a FHIR implementation guide, test CQL content with basic unit tests, and then understand how that CQL-based decision support can be implemented, and list CQL resources for further study. So this slide is at the end as well, but I thought I'd put it here and just give people a chance to get a jump on those if they want. In particular, there's a walkthrough here at this GitHub that actually walks you through all the steps involved in building a decision support content IG with CQL content that can be deployed via some of the reference implementation technologies that are currently available. And CQL Runner, an online ad hoc query environment for CQL that you can point to any FHIR server and see how it goes. So what is CQL for? Well, if you look at the quality improvement ecosystem, this depicts research, payer, public health surveillance, so activities to understand what's actually happening and why. That information feeds into guidelines. So professional societies, guideline development groups, they distill that evidence into best practices. Those best practices then are turned into decision support, making it happen within a local workflow, and those are ideally applied as part of clinician and patient workflow. Then we use measurement and analytics to understand what actually happened, what processes and outcomes have been achieved. We use public health and quality and safety reporting to provide that information back to agencies and interested parties. And ultimately that feeds back into the research, and ideally this is a continuous improvement cycle. So if we take a look at some examples from that ecosystem, this A21 is a recommendation statement from a WHO guideline for antenatal care, concerned with daily oral iron. So one of the recommendations is that iron and folic acid supplementation is an important part of preventing things like maternal anemia, puerperal sepsis, low birth weight, and preterm birth. So that's a recommendation from the WHO based on current best practices. You also see an indicator, so a public health indicator related to that recommendation, trying to ascertain the percentage of pregnant women who received iron and folic acid supplements for greater than 90 days. So ideally, those are different statements about the same concepts from different areas of that quality improvement cycle. And ideally, we would have a way to describe those things in a way that we can share the logic, share the description of the data across that whole cycle. So we don't have to repeat all of those statements in different formalisms at every different point of that cycle. So clinical quality language is specifically about enabling the creation, distribution, execution, and maintenance of computable clinical knowledge. Those statements are narrative, and that's how a lot of that information is distributed right now. But they don't have to be, and they can be expressed formally if we have formalisms that are clinician and domain expert friendly, clinically focused, unambiguous. We can say exactly what we mean, and that are platform and technology independent, and that are sufficiently expressive. So some of the statements about clinical knowledge get pretty involved. So we need a sufficiently expressive formalism to make sure we can share that. So that's kind of the major design goal behind clinical quality language. It was introduced in 2015 as part of the clinical quality framework based on work that was done as part of a Healthy Decisions pilot in the US, specifically focused on knowledge artifact specifications. So how do we share things like decision support rules? It was published in May of 2015 as an STU1. It's gone through several iterations of STU publications. In particular, it was aligned with FHIR in the STU2 publication to make sure that we could use it effectively within FHIR, and to make sure that it was an extension of the capabilities that are already available as part of FHIR. Several pilots in 2019, beginning with the measures that were released in 2018. CMS started using CQL to do measure specifications. So the quality measures in the United States are expressed using CQL and then evaluated. And around this same time, groups like the CDC, Centers for Disease Control in the United States, as well as the World Health Organization, really started looking at how can we use FHIR and CQL to start streamlining implementation of guidelines. So that work is ongoing. The most recent ballot, that should say 5, that's a normative STU5 ballot. We passed ballot, and that is out currently for ANSI review. Pending that ANSI review, the current CQL specification will be published normative. So just a quick overview of the language. It's a declarative language, so it's not imperative. It doesn't have flow control. It doesn't have loops, those types of things. It's intentionally a functional language, no side effects. It's a query language. It's a clinical domain-specific language. It has several features that are specifically focused on constructs that are ubiquitous in clinical logic. It has certain types of physical independence. So it's platform independent, it's data model independent, and it's data location independent. It doesn't care where the data is. It's concerned with expressing what the query should look like. And it exhibits certain characteristics of completeness. It's algebraically complete, it's temporally complete. There's a full set of interval operators, and intervals are a first-class feature of the language, and it's relationally complete. Just a quick overview of the specification. There's an author's guide, which is focused on, targeted at individuals that will be writing clinical quality language. There's a developer's guide that's a more in-depth look at the language, targeted at developers familiar with traditional development languages like Java and C#. Then there's the formal specifications, so the logical and physical representation and the intended language semantics. And then there's the reference, a complete reference for all the operators and functions in CQL. So one of the main design goals of CQL, as I said, was sharing logic. And so one of the architectural features of the language is that we've kept the notion of the model and the terminology separate from the logic. So you can use it with different models, different information models, and you can use it with different terminologies. But we intentionally keep the definition of those aspects out of CQL as a language. So you can say I use something like FHIR to describe the data of interest, and I use SNOMED and LOINC to provide meaning within those logic statements, but I don't define my terminology or my model within CQL. So that gives us an architecture for sharing where we can specify the logic at a high level but precise human readable language, just in text syntax, just like any other query language. Then we have what we call expression logical model, which is effectively the abstract syntax tree. You can also think of it like the Java bytecode, for example, or .NET intermediate language. It provides a layer of separation between the text language and the actual implementation underneath. And this machine readable format is bidirectionally equivalent to the CQL, but it's built in a way that focuses on language processing applications. So it's as easy as possible to pick up and start writing something like a native expression evaluation engine, or a transpiler to JavaScript, or a compiler that spits out Drools rules for execution in a production rules environment, or even translation to something like SQL for execution against a relational backend. So what does it look like? So this is an example library. You've got the library declaration. Oh, sorry, need to go back. Which means I need to find my, so you specify the library, the version, you specify what data model you're using, you specify any dependencies, so you can include other libraries of logic. You specify references to terminology. So in the case of FHIR, we can reference, this is the URL for a value set. We specify the context. So within CQL, you write in terms of a patient or in terms of an organization. It's roughly analogous to the notion of a compartment within FHIR. It means that all of the expressions within this library after this context statement are evaluated as though they were for a particular patient. And then it's a function of the evaluation environment to link that to the patient in context, or to run it over a population. And this is a simple query here, starting with patient as P, where the gender is male and active is true, and the birth date is 30 years before today. It's just a fairly contrived example, but shows a simple where clause. And a library then consists of any number of these defined statements that let you build up expressions. So how you actually get to data within a library is through the retrieve. So you specify your terminology, and you can use that terminology within a retrieve. So these brackets are a retrieve, and within that you specify the type of data you want to retrieve and a reference to a terminology that specifies the meaning of the data you want to come back. So observations that are tobacco smoking status observations, and then you can say where the status is final and amended. A lung cancer diagnosis, for example, is conditions that are have the code of lung cancer, where the clinical status is in condition clinical status. So let's dig into that retrieve a little bit more. When you're retrieving by code, specifically against FHIR data, what that will translate to is actually a get against the observation endpoint. And so for a given patient, that will actually result in a code of that LOINC code for tobacco smoking status, as we declared there. And so you want to align those retrieves with documented search parameter capabilities. So for example, this is the search parameter definition from US core smoking status observation in the US core profiles. And it says systems shall support searching using the combination of patient and code. And so this observation we know is aligned with that search parameter definition. You can also retrieve by value set. You can say get the base condition where the code is in. This search parameter is a should, so implementations might not support that. At least US core based implementations. So in that case, one, the search is by value set, so the servers would actually need that terminology available to them. So that's the function of that globally unique URL for the value set to specify where and how you could actually obtain that. But in the absence of global resolution of value set URLs, you need to have a way to distribute that. Or you could actually inline the terminology, and some engines are actually doing this now to avoid the problem of terminology distribution. So instead of asking for code in that value set, the engine will actually expand the value set and inline all the codes and pass that as the search. So let's look at slicing example. Slicing is one of the more common profiling techniques within FHIR. In particular, you can do things like say that there's blood pressure components of systolic and diastolic. And you do that by slicing the component element of an observation. So we can just define within a query in CQL a let to say that systolic BP is accessing the singleton from that component where the code is systolic blood pressure. So we're actually realizing that slice as the expression systolic BP and diastolic BP, and then we can use those within the query. So where the systolic BP value is less than 140 milligrams of mercury or millimeters of mercury. Another example is accessing extensions. So I can actually say, let the birth sex be the singleton from that extension where the URL is US core birth sex. And then I can use birth sex as accessing that extension. And I can do the same with complex extensions where I can let a race be the extension, and then I can let the OMB category, which is a subcomponent of that extension, actually dig into that race extension where the URL is OMB category. then I can use those OMB categories and OMB category and detailed to access those components directly. So I can set that up, but you can see that that's kind of a lot of code. It would be great if the slicing could be informed by the profile definition, because the profile actually says systolic BP is a slice of the component element with a particular code. And so by using a model that's informed by that profile definition, we can actually retrieve observation BP directly. And now we have all of that logic expressed with this much more simple expression. So I can retrieve observation BP where the systolic BP value is less than 140 and the diastolic BP value is less than 90. And I can do the same with extensions. Extensions are really just specific kinds of slices of the extension element. And so by building a model that is informed by that profile definition, I can actually write an equivalent, much simpler expression that allows me to access those race, OMB category, and detailed elements as first-class elements in the model. So how do we take a CQL library and actually wrap it up into FHIR? So we use the library resource in FHIR to do that. And specifically, we use the URL, version, and name components of the library, as well as the content to actually wrap all that up. So the URL is the same as the base canonical URL for FHIR IG, and then the library, and then the name of the library. And that name and version have to match the name and version of the library. And then we use the content element to communicate the actual CQL content. So there's a sample content IG in the CQ framework repository that illustrates how to do that. And in the publisher, there's actually a binary adjunct files parameter. So you can add a parameter to say path binary input CQL. So this path binary parameter is a directory in your implementation guide source that contains CQL files. And what the publisher will do is go through and translate all those CQL files to ELM using the CQL to ELM translator. And then it will go through all of the library resources that have a content ID flag here, and it will use the name of the CQL file to pull that content in. So it will translate, pull it in as base64 encoded content within the library resource. So there's documentation on that binary adjunct files parameter there. So as part of that loading, the CQL subsystem within the publisher will process each file and do syntactic and semantic validation. It'll report any errors that occurred as part of that process. And then it'll base64 encode the CQL and the application ELM XML or ELM JSON content, depending on how you want that to come out. It'll extract and set the related artifact element of the library based on includes in the CQL. It'll set the data requirements based on any retrieves in that CQL and expose those as the data requirements elements. It'll extract and set parameters in the CQL and set the subject based on the context in the CQL. That's in italics because that's still, I think that's still a work in progress. So one of the things you can do in the publisher then is set this CQL options file. There's a CQL options JSON example, and you can use different options that you can set to the CQL publisher or translator But in particular, you can specify the formats that you want. So XML and JSON, and that controls what kind of content will actually be put out in the library resources. What that means then is that your library resource is part of the implementation guide. It's a conformance resource that's distributed as part of your implementation guide content, just like profiles and value sets and all of that. In particular, those resources are actually in the NPM package. And what we've done is specified a way for you to reference those libraries in your CQL. So the sample content IG is actually referencing an example library from the sample IG. Sample IG has this example library. Sample content IG references that example IG, and now we can use CQL content from libraries shared from dependent IGs. So I think that's pretty cool. Libraries, we also have a narrative template there. This is one way to do it. The publisher will actually produce a really nice library output already, but you can also override that if you want with template behavior there. And that shows how to do that. So this is a narrative example. Basically all of the elements that are relevant for related artifacts, parameters, data requirements, and the text CQL become part of the narrative of that library resource. So when that's published in an implementation guide, you can see immediately what the content of that library is. So some of the tools that are available, there's an Atom editor. That's a simple open source text editor that's fairly widely used. There is a language CQL plugin for that Atom editor. You can download that, and we keep that up to date, and that's constantly being improved as well. PR is welcome. Currently, it provides syntax highlighting, error detection, translation to ELM, and evaluation and testing. So in particular, what you can do is inside your input folder, you have the CQL that contains all of your source CQL. Then as a peer to that, you have a tests folder. And if you have a folder within that tests folder named the same as your library name, then that's basically a set of tests that will be run against that. And each folder in there is a test scenario that's currently it's based on patient. That's the only testing context that's supported. But the patient ID is the name of the folder. And then there are all of the resources in that folder are available to the CQL for that test case. So you can have any number of test cases and you can test any number of libraries. And the vocabulary that you need is available in the vocabulary code system and value set folders there. So you can make value set content available to the test as well. So for example, in this tobacco smoking status test case here, you just right click and say execute CQL or press F5 in the latest Atom plugin. And it will run that and tell you for each test case. So this is running the former smoker test case. And for each of the expressions in that library, you'll get the output of that. So current smoker false, quit within the past 15 years true, 64 pack years, 30 pack years smoking history, so all of that. So that's how you can unit test the content that you're developing. So if we look take a step back then and look at what we're doing here, the base specifications like the FHIR spec itself and the layers of the FHIR spec there, FHIR path, CQL, CDS hooks, and SMART. These provide a foundation. And then you see things like model IGs, so things like the International Patient Summary or US Core and QI Core. These are sets of profiles that are intended to enable a broad range of use cases. They're typically focused on administration and clinical data within FHIR, and they're focused on particular realms. So they're about how do we enable exchange between systems in these spaces. And then you have specification IGs that are about things like for quality measure specifications, how do I use the FHIR resources to express things like quality measures or CPG on FHIR? How do I use these resources to express computable content for clinical guidelines and decision support? And these specification IGs then provide guidance for how to use the content within the base specification together with other foundational standards to deliver things like quality measurement and reporting and decision support. And they provide conformance criteria for what we call content IGs. So a HEDIS IG might be a set of quality measures. HEDIS is a healthcare effectiveness data and information set. That's a set of measure specifications that are used quite extensively by payers in the United States. And the HEDIS IG is a set of those HEDIS measures expressed as FHIR profile or resources that conform to the profiles specified in the quality measure IG. Another example is opioid prescribing. So we have opioid prescribing guideline in the US that has a bunch of recommendations, and the CDC opioid prescribing IG is a representation of those recommendations in computable form using the FHIR resources. And WHO ANC is another example of a content IG that helps to streamline implementation of guidelines. So looking specifically at that antenatal care example, this is recommendation A2 that we saw at the very beginning. It has the narrative content, so just the description from the guideline, and then a functional description, so kind of a breakdown into pseudocode, but still very clinically focused and high level. A flow diagram that kind of illustrates how that should be applied, when it should be applied, and then the actual computable content. So an ANC common library, the plan definition that shows how to plug that into a workflow, the CQL library for the iron and folic acid recommendation logic. And all of those are packaged then as a FHIR implementation guide to deliver that content. So it also has profiles and terminology. So just like any other implementation guide, you've got profiles that specify this is an LMP observation, and then the terminology associated with that is made available there. And specifically plan definitions that support when defining decision support as an event condition action rule. So when some event occurs, in this case, the named event ANC contact, if some condition is true, in this case, the has anemia expression within the ANC recommendation logic, then you perform some action. In this case, we're specifying that daily elemental iron should be increased to 120 milligrams because the patient has anemia. So that references an activity definition that's a template for constructing a medication request to actually prescribe 120 milligrams of daily elemental iron to the patient. And then you can pull all of that together, plug it into a clinical reasoning implementation and then that is exposed using CDS hooks. So there's a CDS hooks API endpoint for this service, and you can register that with an EHR, and when the order select operation occurs, the CDS hooks request with patient data is sent to that API. That plan definition processing occurs and evaluates the CQL logic against the data that was provided. And then that's turned back into a CDS hooks response for display to the user. So in particular, that walkthrough that I've linked walks through building all the way up to that point and deploying that content that you build into a sandbox and then plugging that into the CDS hook sandbox so you can evaluate it. So what did you learn? Well, hopefully this was informative. So describe clinical quality language as an HL7 clinically focused domain-specific query language for sharing clinical logic. Explain how and where it's being used. It's being used extensively for decision support, quality measurement and reporting, and public health reporting. And use CQL to express simple decision support logic. Include that into a FHIR implementation guide. Test it. Understand how it can be implemented, and list further resources. So during DevDays, you can find and reach me here in the speakers gallery. You can email me directly. You can go to Zulip. You can also find me on LinkedIn. And the resources. So specifically, this content IG walkthrough. Let's go there. And the CQL runner. So CQL runner gives you, there's a couple examples that are there by default. You can run those. You can also configure that to point to any source data that you want. It's currently pointed at a sandbox that's loaded with data that makes the examples run, but you can point it wherever you want, and you can point it at any particular patient and run your queries. So that's what I have.
Great. Really good, dense presentation, really interesting. So there was a first question in the chat, whether you would be able to share the links in the chat so that it'd be able to paste those links on the Wova chat. And the presentation will be made available by DevDays, so it's not made available straight away, as far as I know. That was the other question. Then received via Zulip a bunch of questions. So one question was quite general. So how widespread is community and institutional support of CQL right now? So could you say something about that?
Sure. So as I mentioned, this is the third year that we've been using CQL to specify clinical measure specifications here in the US. And we are also in, it's being used in quite a lot of places. Let me go to that link there. This is a community projects page that we maintain. So these are all the open source community projects that we're aware of. There's a JavaScript engine, a Java execution engine. There's a Blaze implementation that plugs it into Datomic. There is a CQF ruler that is a FHIR server plugin. There's a CQL on OMOP that translates to OMOP for evaluation against Odyssey. And if you're aware of anything, feel free to add to this. But it's also being used in several pilot projects here in the US around opioid decision support. It's been deployed with pain management summary as a smart on FHIR application. It's being used in some of the payer documentation templates and rules and prior authorization work. So in that use case, providers need to provide additional information to payers to support authorization of services. And that's one way to enable that is to provide a questionnaire, and the questionnaire uses CQL to fill out additional information that's available from the record. It's also being incorporated into public health reporting specification to support evaluation of additional rules to support determination of suspected reportability. And as I mentioned, it's being used within the WHO as part of expression of guidelines, antenatal care, family planning, sexually transmitted infection, several of the guidelines there, and more in progress. So,
great. So I've got another question by someone who's working in more the RDF domain, which is one of the representations of FHIR. So he's asking whether there's any conversion from CQL to Sparkle libraries supporting that.
So we have run it. We have a implementation that will run quality measures in Spark pipeline. The way that we actually do that, because it's just a Java engine, this Java execution engine, it just runs as part of that data pipeline. We have one plugin, one environment that's using that just as raw JSON and made available via the file system, and that runs quite well within the Spark pipeline. And then there's another implementation that's actually using a different rule engine and has a Parquet format. If you look at the Bunsen project, that uses that format and can run CQL against that format.
Okay.
Yeah, hopefully that helps.
Yeah, that's answered the question. So we've got 2 minutes left, maybe one final question. I think you touched on this, but that's sort of where do we draw the lines between the concern of CQL and in relation to CDS hooks? I think you touched on that quite well. So where do we have the separation? Where have the two different concerns? Where do they end and when does the other begin?
Yes, let me go back here for that discussion. So clinical reasoning module in FHIR is focused on two primary use cases. One is kind of the runtime behaviors. What does the API actually look like? How do you call these things? How do you integrate them? And the concerns with how that call happens and how the processing happens in that request response. And that's all CDS hooks, and it doesn't say anything about what happens behind that request, what happens behind that layer. And that's really the second use case of clinical reasoning, which is about how do I share the behavior behind a particular implementation in such a way that different implementations could use that same content to get equivalent behavior in different environments. And that, I think, is where the separation is drawn. So CDS hooks doesn't care how that actually gets implemented.
Yeah.
and clinical reasoning provides a way to formally describe what happens without specifying how you actually make that call. You can use clinical reasoning with other evaluation APIs, and you can use other implementation formats and frameworks, obviously behind CDS hooks. So
great. So I think we're spot on time. Perfect landing there. Really dense talk, really practical. Really appreciated it. I hope all the S&Ds enjoyed it too. And please remember to rate the talk, and also you can continue the discussion in the chat and in the session Q&A, where Bryn will be able to answer questions after the session ends. So that's about it. I wish you a nice remaining Dev Days, bunch of interesting sessions later on, and tomorrow and Friday. So have a nice evening in Europe and a nice afternoon in the US.
thank you all.
Thanks. So we could stay in, Bryn, for just 5 more minutes, because people usually look into the Q&A at the end of the talk, because once they're looking at the screen, they don't see the Q&A box. So I got it.
So there are more Q&A. I'm not seeing those.
No, there aren't anymore. So actually they were sent, so I had a bunch of questions, which I got sort of in advance, but those were the questions. So if somebody else posts further questions, they would be there. They would be there. One question I'd love to have asked is, which FHIR servers have implemented CQL to date?
So there's an open source plugin that will take that Java-based CQL engine and add that as a capability to the Happy FHIR server. We call that a CQF ruler. It also supports exposing the CDS hooks endpoint and supports implementation of a couple of the operations around plan definition usage. There's a CQL evaluate operation as well.
So you'd only work with using HAPI, right? So would it be able to work with a different FHIR server, the open source version?
You would have to write like a plugin or something to support that.
Or that, yeah.
But yeah, the Java engine itself can run against any FHIR server, but that runs out of process, right? It's basically turning the retrieves into requests against the FHIR server.
Exactly. Yes, we'll wait 2 more minutes. And then I think that so I'm really looking forward to seeing this. I mean, it's really been missing having the implementation done in most. We use the FHIR server, so we're looking forward to having that implemented there. That's soon coming up. Yeah.
In what server?
In a FHIR server.
Oh, in the Vonk. Okay.
Vonk, yeah.
All right. There's also a JavaScript engine that would make it pretty easy to plug into any JavaScript-based servers.
Oh, I didn't know about that. So could you point me to it?
Yeah, absolutely. It is on that community projects page.
Okay. Yep.
Yeah, JavaScript
Yep.
execution engine.
Yep.
And there's a FHIR plugin for it, and there's actually CQL testing services as well. But yeah, that's what we use when we plug it into client-side browser technology with Smart on FHIR. So
yeah,
we've got it running in several Smart on FHIR apps that use that JavaScript engine.
Okay. So I think we're through. So the 5 minutes passed. So I'll just end the recording now, and then I'll end the session. So thanks a lot again, Bryn. So hope to see you around for real sometime in the next day.
Yeah, that would be good. Thank you for moderating. Appreciate it.
No problem. It was a pleasure. Bye. Bye-bye.
Bye.